Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. Which compound forms both hydrogen and oxygen at the electrodes when a concentrated aqueous solution is electrolyzed? And you have these four choices here. The first key word that you must pay attention to here is concentrated. A concentrated aqueous solution. Because when you have a dilute solution of any one of these, what it amounts to basically is the electrolysis of water. You get hydrogen at the negative electrode or the cathode, and you get oxygen at the positive electrode or the anode. But always you have oxidation at the anode and reduction at the cathode. And I say always because in the voltaic cell or the galvanic cell, then the charge on the cathode and the anode gets reversed. But the process that happens at the anode is always oxidation. And the process that happens at the cathode, always reduction. And it's useful to remember that reduction is gain and oxidation is loss. But in this question, you don't have a dilute solution. The solution is concentrated. And when you have a concentrated solution, then it's important to use your knowledge of the electrochemical series. With potassium at the top of this electrochemical series, then sodium, iron, lead, and then comes hydrogen. Below hydrogen, here, you would have copper and silver. So when you have a concentrated solution, and it includes potassium and sodium, like potassium iodide here and sodium chloride there, then you still won't get those metals being discharged because they are still way above hydrogen on the electrochemical series. And it's only when you have a concentrated solution, first of all, because if it's dilute, you're only going to get hydrogen. So if you have a concentrated solution and then you happen to have a metal ion that is below hydrogen on the electrochemical series, like copper, silver, or gold, it's only then that you would get these metals being discharged in preference to hydrogen. Potassium iodide, you're going to get hydrogen at the cathode. And here too, you're going to get hydrogen at the cathode. Now in D, where you have silver nitrate, you are actually going to be able to get silver at the cathode. But the question says, which compound forms both hydrogen and oxygen? And of course here, sulfuric acid, with hydrogen being present here, here you'll get hydrogen. So at this point, you've only eliminated D as a possible choice. So D is not your answer. Now, how do you differentiate among A, B, and C? Well, of course, the short way is to simply memorize the answer to this type of question. Whenever you get sulfuric acid or nitric acid and it's concentrated and you electrolyze it, then you're going to get hydrogen and oxygen. And of course, C should be the answer. But what's the justification for eliminating A and B? When you have a dilute solution, you're going to get hydrogen and oxygen. But when you happen to have a concentrated solution, you won't get potassium and sodium when it's concentrated. In fact, the system needs to be molten for you to extract the metal by electrolysis. But when it's concentrated, then this anion, I minus, and this chloride ion, they can be discharged by electrolysis in preference to oxygen. But it doesn't happen when you have nitrate. So you actually won't get nitrate being discharged here, but you'll get oxygen and silver here. Here you'll get oxygen also, because when you have sulfate and nitrate, you get oxygen. But when you have the halides, iodine, chlorine, and bromine, then they will be discharged only if it's concentrated. So only when you have the concentrated aqueous solution and it's a halide, then those will be discharged. If you have a nitrate or a sulfate, then oxygen will be formed at the anode. To get these metals like potassium and sodium, which are high up in the reactivity series, you need a molten substance. And it's useful to remember that the electrolysis of concentrated sulfuric acid, concentrated nitric acid, will give you hydrogen at the cathode and oxygen at the anode.